Ladies, 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 roll up for Dr. Clive's fabulous beauty treatment for the removal of all unsightly blemishes on your skin using the power of electricity alone, using this wondrous device bought off eBay for just under £6 that physically burns spots off your skin. Seriously, this device is actually designed to burn your skin. Let me get the information in here. The listing. Laser freckle removal. It's not a laser. Laser freckle removal pen machine, skin mold, dark spot, face wart, tag remover. Came in at £5.19 plus 50p shipping. This was my second attempt at buying one. The first one just didn't turn up and I got a refund. This one came from a seller called Perles Saison, Perles-Saison. And it came through quite quickly. But it does say it's for removing moles and skin spots and stuff like that. And I'm no doctor, but I've always been under the impression that interfering with moles is not a good idea. But it says mole and spots removal pen. I would say not really recommended for mole removal. But anyway, let's read the instructions. High and new technology adopted will guarantee a rapid effect of beauty for you. The electric ions can help remove any spots such as freckles, age spots and verruca plana without any damage or side effect. Mole removal. More attention should be paid to the depth of moles. Some appear to be on the skin surface, but actually they are rooted deep in the tissues. This is part of the problem. So you'd better burn off the models by moving the pen in small squares. No! For moles in the depth of skin, infection should be avoided and apply some cream 2 or 3 days before the skin recovers, which will prevent cavity from forming, and cream can be used without any infection. Oh, it's horrible. Tattoo removal. Oh, definitely don't use this for tattoos. Large needles should be used to remove tattoos since it usually covers a large area. The method is similar to that for removing spots, but the time is a little longer. For tattoo in large area more than 3 centimetres, the removal should be conducted for several times, otherwise potential infection may lead to disastrous consequences. Both the beautician and customer should be quite cautious and go to see doctors without delay in the case of serious infection. Then it goes on to say, test on fresh pig skin is recommended for the first use, just to get the hang of using it, and it's not for children and amateurs. Yeah. Okay, so now I'm going to show you this burning my skin. I'm sorry about that. If you don't like that, just turn away from the screen at the moment, and we'll zoom up on a sort of hard skin callus here. And to turn it on, you press and hold the button here. And let's just use it at level 1. And when I press the button down here, that goes green to show it's putting output. And I have to say, I've had mixed results with this. It's been crashing quite a lot. But here is a hard callus, and I'll just try. It's crashed. I think it's fully charged up. Let's try it in the next setting up. See the skin burning and... yeah, see, is this a good thing? And it's crashed again. Maybe this is why they're cheap. But yeah, it does physically burn your skin. Now, MD, who has experimented in the past, like I did, with high voltage, high frequency power supplies. When I was younger, I had a whole phase of building. Basically, I was trying to build a neon tube drive that would run off batteries. And I discovered the hard way that when the cable insulation isn't up to scratch, or through capacitive coupling, which this also uses, you can actually, I was handling wires and suddenly smoke started going from my fingers, and where the wires were running across the fingers, it burnt them as it has here. You can see it's gone dark there where it's burnt. And it's just the high frequency arcs burning onto the skin. To show you it is high frequency, high voltage, I shall turn this on, click it up to a higher setting. I'm not sure how long it will run for. It tends to cut out when you do this, but watch the tube. See it lit up? And it's cut out. It doesn't like that at all. But that shows it's putting out the high frequency, high voltage. It comes with a couple of tips. It comes with this one here. Let's zoom up a little bit so you can see the tip. And it's just a fairly generic probe type tip. And this unscrews. And then you get this set of needles. This might be what they're talking about too. I'm really not sure what this is. But the needles are just so sharp that, I'll try and get a reflection. There's a reflection. It is very, very sharp. And from what I can see, I guess you feed it through the middle of this bit here, this collet type thing, which isn't really a collet. It doesn't close in it. And then it pushes it down the inside Not sure why it's doing that. Maybe they're using standard needles. And you end up with a fairly stoutly mounted, super sharp needle. That's just freaky. That's freaking me out. I'm going to remove that now. Not into sharp, pointy needles and burning flesh, to be honest. I don't think many of you are. But what's of real interest here is what's inside this. I think we should open it. It may contain useful components, because sometimes if it is a reject component because they've been having problems in cutting out, which isn't really surprising because your basically act as an antenna for RF energy, and that electronics tend to get a bit upset when you do that because the electronics themselves try to radiate that high voltage energy, and it creates a potential difference and it crashes processors. So let's open this up. The 3 LEDs, incidentally, when you turn it on, you press the hold and it does the first one, then the second, then the third. They go green when you push the button when their output's on. When you're charging it, that's the battery charge indicator. So I shall turn that off. And I shall bring in the spudger. Now, I should have thought of this beforehand. I don't see the spudger here because I've buried it, because I've been doing lots of experimentation and building. Yeah, that wasn't well planned. If I don't find it in a second, I shall pause. Oh, I found it. Found it. Right. Let's see if we can open this without plunging this deep into the lithium cell inside. I'm not even sure how easy it's going to come apart. I don't know if it's clipped together or if it's been welded together ultrasonically. It does seem very tight. Extremely tight, in fact. Oh no, I think it is just clipped. I could be wrong. Okay, oh, that's promising. Righty-ho, based on that, I think I can probably pop it in here. Well, that's pretty good, that's pretty good. Oh, nice. Oh, look at this. This is just a candy box for us. There's a screw. This transformer is beautiful. That is just fantastic. That's totally worth it on its own. That is like the transformers they use for the cold cathode supplies, but this one is totally potted in resin. It's got the multiple windings. It's designed to be pretty much open circuit, which it is in many instances. We've got the lithium cell, which I'm guessing might be rated for 1 amp hour. Oh, this thing is just full of goodies. Very, very intrigued to see what is underneath. I'm guessing maybe could be the 8-pin microcontroller, might be more pins. I'm guessing some battery protection circuitry, like either a dedicated charge chip coupled with DW01 perhaps. Battery protection. Oh, it's stuffed. It's got quite a lot. There's an inductor. What's that for? Is it maybe it's using a separate power supply? Maybe it's filtering. There's a transistor here, which is, let's brighten this up now. Let's get the white things out the way, and then I'll just brighten this up excessively, probably. Yeah, kind of excessively, that's all right. Let's zoom down and take a closer look. Button. This chip here is almost certainly going to be a sort of TP40560 type thing. 5056. Okay, so that's the current limiting. I see a diode here in the input as well, so that's for polarity protection, possibly maybe to start dropping the voltage. We've got the charge regulation chip, which limits the current. We've got a couple of little chips down here. One of them may be a DW01. They're very hard to read, but I'm guessing they're the battery protection chips. We're going to bring in my other little magnifying glass here. See if we can actually read those. The big chip here, which is the microcontroller, has nothing printed on it. There's a surprise. This one up here is the DW01. This one here will be the, what's the 8205? It's usually the MOSFET, 8205S. It's the MOSFET. That's the battery protection circuitry there. I wonder what this transistor's for. This might be multiplexing for the LEDs, so it can control, because they're bi-colour LEDs, it might, oh no, it might not actually. Not sure about that. I would expect 2 transistors for that. I think it might literally have, because it's multi-pin LEDs here, it might actually be using 1 pin per colour. It's got this little inductor here, and this little component here that I'm guessing that's a switching supply. This might be an attempt to filter the supply going out to there to try and avoid the noise coming back to this processor, because this is what's crashing when things go wrong. That little chip, oh, it looked quite posh, FP6276B, and it's got a logo on it. That's quite interesting. Let's see if I can show you this. Is that visible? Then the big transistor, there's a capacitor, there's a little diode, which may be for protection of the transistor, and it will be feeding the primary of this transformer here, which will be a central core. It's almost like a cooker igniter transformer. You can see the connections going in here. You get a fairly heavy connection going into the back, and another heavy connection coming out this end. That's the common going down here. That's see the output for the high frequency. Oh, you know what? It must be coupling through, when you hold it, it must couple. I was kind of expecting metal plate in here. I thought that where you hold the button, oh, the button that's just popped out, I thought there might be a metal plate. That's why it's kind of like holding it sideways like that. I'm thinking it may be using the general mass of the battery, but keep in mind this is operating at very high frequencies, sort of RF-y types of frequencies to generate that sort of effect. I mean, I say RF, well, probably in the region of 20 or 30 kilohertz is a wild guess there. And one connection is going to the end of that high voltage circuitry. The other one is going on to the general mass of ground, I think, on this circuit. And that is how they're coupling the other side to the body. So when you're using this, you are basically an antenna, and the probe is actually conducting. It's basically radiating the energy and trying to find its way back to your body, which is why if you're doing it yourself, I'm guessing that if you were treating someone else, it would be beneficial putting your hand on them, maybe caress their thigh gently while you're doing it. I'm just going to have to be careful here in case I turn this on. But then, you know, that would couple the current so you could actually burn their flesh. That's lovely. So things that are worth having in this. This high-frequency output transformer is great. The lithium cell's fine. You could use it to burn your flesh if you want. I don't really recommend that. But it's got the charging circuitry. It's got the controller. I wonder what other applications there are for this. Driving a little neon tube, but then it's already shown it tends to crash when you do that, which is odd. Maybe that's why they are so cheap. Maybe they've built these and then discovered that there is that slight sort of high-frequency RF issue that causes microcontroller problems. So maybe not great for its intended purpose. I mean, some people will use it for that. But for us, it's a complete candy box with the battery inside and the charge circuitry and the special transformer at the end. It's really quite neat. The magic skin incinerator is the gift that keeps on giving. It's got some interesting circuitry. I thought that this little chip here was doing the sort of driving of this transformer here, but it turns out that this is a 500 kilohertz boost converter, and that is way too high a frequency for that core in there. So what it's actually doing is it's using this inductor that I thought was just like filtering, but it's using this inductor to boost the voltage up, to charge that capacitor, and then present a high positive voltage to one end of the transformer, the primary of the transformer. The other end of the transformer, primary, is coming along this track here, through these plated through holes, and onto this MOSFET, which is then switched by the microcontroller over here. So that's what's actually doing the lower frequency switching. That's just a boost converter to raise the voltage up. Talking of raising voltages up, or indeed dropping them down, this that looked like a transistor, but is actually called U2, it's a 662K, which is a 3.3 volt voltage regulator. I'd guess quite high current, low dropout, and it's basically acting as a power supply for this circuit here. And that's it. So it's quite smart. It's got that diode in the input. It's got the battery charging circuits, the battery protection circuit, the microcontroller, the voltage regulator for that, the boost circuit to step the voltage up and then switch it through the MOSFET controlled by the microcontroller. All very neat indeed.